Did you know that trigonometric equations that require the use of an identity are some of the most complicated trigonometric equations to solve? By the end of this video, you'll know exactly how to solve these equations because we'll have walked through the solution to 4 types of example problems. Welcome to Understand the Math. We've created free guided notes that you can use as you watch this video and placed a link to them in the video description below. There's space in the notes where you can fill out the answers to the examples that we're going to do and learn more, because you can't just watch someone do math, you need to do it too. Before we go over these 4 example problems, we're going to quickly walk through the steps that we need to follow to solve these problems. The strategy that we'll use is to find a trigonometric identity that will simplify the equation to one that can be factored. To find this trigonometric identity, we're going to look at the more complicated terms first. Here's the steps that we're going to follow. The first step is to substitute an appropriate trigonometric identity into the equation and then simplify it. The second step is to reduce the equation to sine theta is equal to a constant, or cosine theta is equal to constant, or tangent theta is equal to constant. The third step is to determine the quadrants for theta. The fourth step is to plot the value of sine theta, cosine theta, or tangent theta on the unit circle. And then the last step is to find all solutions for theta. We'll use reference angles to find theta. If theta is in the first quadrant, it's already equal to the reference angle. If theta is in the second quadrant, it's going to be pi minus our reference angle. In the third quadrant, it will be pi plus our reference angle. And in the fourth quadrant, it's going to be 2 pi minus our reference angle. In all 4 of the examples that we're going to do, we'll find all solutions to the given equation, and then we'll find solutions in the interval from 0 up to 2 pi. Let's look at our first equation. For our first step, we notice that cosine squared is the more complicated term, and we can write cosine squared in terms of sine squared if we use the Pythagorean identity. We have sine squared theta plus cosine squared theta is equal to 1, and that gives us cosine squared theta is equal to 1 minus sine squared theta. We can plug that in, and we have 1 plus sine theta. And on our right-hand side, we have 2 times the quantity 1 minus sine squared theta. Let's go ahead and simplify this. This is 1 plus sine theta is equal to 2 minus 2 sine squared theta. Let's bring everything to the left-hand side. That gives us 2 sine squared theta plus sine theta plus 1 minus 2 is equal to 0. This then becomes 2 sine squared theta plus sine theta minus 1 is equal to 0. Let's now factor the equation and reduce it to sine theta is equal to a constant. To factor it, we have 2 sine theta and sine theta, and then we have a 1 and a 1. That's a plus, and that one's a minus. So this gives us 2 sine theta minus 1 is 0, and sine theta plus 1 is equal to 0. Solving for sine theta, we get sine theta is 1/2 for our equation on the left, and for our equation on the right, we get sine theta is equal to -1. Let's now determine the quadrants for theta. For our first equation, sine theta is greater than 0, so theta is going to be located in quadrant 1 and in quadrant 2. In our second equation, sine theta is negative, but it's equal to -1. So theta is going to be located at a coordinate point. Let's now plot the value of sine theta. In our first equation, sine theta is 1/2. We remember that sine is related to y, so we're going to plot when y is 1/2. So that's going to happen here and here. So we'll have one angle here, and we'll have our other angle here. And our first quadrant, theta, is going to be arc sine of 1/2. And we know that's equal to pi over 6. Plotting it really helps you remember if it's pi over 6 or pi over 3. Those are really easy to get confused. In our second quadrant, theta is going to be pi minus theta sub r. So this is pi minus our angle in the first quadrant, which is pi over 6. And this is 5 pi over 6. For our second equation, sine theta is equal to -1. Sine is y, so let's plot when y is equal to -1. So we can see that theta is going to be equal to 3 pi over 2. Let's now find all solutions for theta. From our first equation, we found that theta was equal to pi over 3. And for all solutions, we add on 2n pi. And then we also had 5 pi over 3 plus 2n pi. Between 0 up to 2 pi, theta is equal to pi over 3 and 5 pi over 3. For our second equation, sine theta was equal to -1. We found that theta was 3 pi over 2, so we'll write that down. And we add on 2n pi. Between 0 and 2 pi, theta is equal to 3 pi over 2. And remind ourselves that n is an integer. Let's now look at our second equation. We notice that sine 2 theta is the more complicated term, so let's write down a trigonometric identity for sine 2 theta that has cosine in it. We can use sine 2 theta is equal to 2 sine theta cosine theta. Let's plug this in. That gives us 2 times the quantity 2 sine theta cosine theta minus cosine theta is equal to 0. Let's clean this up. This is 4 sine theta cosine theta minus cosine theta is equal to 0. We see that we can factor out a cosine theta, and we're left with a 4 sine theta minus 1 is equal to 0. Let's now reduce this to one equation with sine theta is equal to a constant and one equation with cosine theta is equal to a constant. So our first equation will have cosine theta is equal to 0. And for our second equation, we'll have 4 sine theta minus 1 is equal to 0. This is going to give us sine theta is 1/4. Let's now look at the quadrants. When cosine theta is equal to 0, theta is going to be located at a coordinate point. When sine theta is equal to 1/4, we know that sine theta is greater than 0, and that tells us that theta is going to be located in quadrant 1 and quadrant 2. Let's now plot the values on our unit circle. Our first equation, cosine theta is equal to 0. Cosine is related to x, so let's plot when x is 0. So that's going to be here and here. And for our second equation, sine theta is equal to 1/4. Sine is related to y. When y is 1/4, it's going to be here and here. So we're going to have this angle in the first quadrant and we'll have an angle in the second quadrant. Our theta in the first quadrant is going to be arctan of 1/4. When we put this in a calculator in radian mode, theta is approximately 0.2527. In the second quadrant, theta is equal to pi minus theta sub r. This tells us that theta is approximately pi minus 0.2527. So theta is approximately 2.8889. To find all solutions for theta, we go back to our first equation, and we know that our solution was pi over 2 and 3 pi over 2. So our first theta is pi over 2 plus 2n pi, and our second theta is 3 pi over 2 plus 2n pi. And then between 0 up to 2 pi, we have theta is equal to pi over 2 and 3 pi over 2. And n is an integer. For our second equation, we found that theta is approximately 0.2527, and now we add 2n pi, and then likewise, theta is approximately 2.8889 plus 2n pi. So that gives us theta is approximately 0.2527 and 2.8889. Let's now look at our third equation, and it's written in terms of secant and tangent. We notice that secant squared is the more complicated term, so let's think about an identity that involves secant and tangent. Take a minute, you can even stop the video, and see if you can think of what that identity should be. We have the identity 1 plus tangent squared theta is equal to secant squared theta. Let's plug that in. So on the left-hand side, we're going to plug in 1 plus tangent squared theta. And then we subtract the tangent theta that's already up there, and the right-hand side is 1. Let's rearrange this so we can factor it. So we have tangent squared theta minus tangent theta plus 1 minus 1 is equal to 0, pulling that 1 over from the right-hand side. So this gives us tangent squared theta minus tangent theta is equal to 0. We can now factor out a tangent theta, and we're left with tangent theta minus 1 is equal to 0. This is going to give us two equations that are going to reduce to tangent theta is equal to a constant. Our first equation is going to be tangent theta is equal to 0, and then our second equation is tangent theta minus 1 is 0, which gives us tangent theta is equal to 1. Let's now think about the quadrants for theta. Let's remind ourselves that tangent theta is equal to sine theta over cosine theta. So when tangent theta is equal to 0, that is where sine theta is equal to 0. And that is going to happen at a coordinate point. Let's now think about tangent theta is equal to 1. Tangent theta is greater than 0, so that tells us it's going to be located in quadrant 1 and quadrant 3. We only need to be worried about the solution in quadrant 1 because tangent is pi periodic, and we can easily get the solution in quadrant 3 from the solution in quadrant 1. Let's now plot our values of tangent on the unit circle. For our first equation, we have tangent is 0 or sine is 0. Sine is related to y, so let's plot when y is 0. So that's going to happen here and here. And then for our second equation, in our first quadrant, theta is going to be arctan of 1, and we know this is equal to pi over 4, and that's located here. And then we'll also pick up a solution in quadrant 3, and that's going to be pi over 4 plus pi, which is 3 pi over 4. We also could have gotten that using our reference angle, knowing that our theta was pi minus pi over 4. Let's summarize these solutions on our next page. From our first equation, we saw that theta was equal to 0 and pi. Let's just put that up here. So theta is equal to 0 and pi. And we can write this together and say that theta is equal to 0 plus n pi. So between 0 and 2 pi, theta is equal to 0 and pi. For our second equation, we found that theta was equal to pi over 4 and 3 pi over 4. Instead of writing both of them, we can summarize this and say theta is pi over 4 plus n pi. And then between 0 up to 2 pi, theta is pi over 4 and 3 pi over 4. And n is an integer. Let's now solve our last equation, and this is by far the hardest equation. When we look at this equation, we notice that there's no easy identity that relates just cosine to sine. However, we do have an identity that we've actually already used that relates cosine squared to sine squared. Let's write that identity down. So we know that sine squared theta plus cosine squared theta is equal to 1. So let's think how we could relate this identity to our given equation. We notice that we have sine on the right-hand side. So what if we square both sides to get terms that have cosine squared and sine squared in them? Let's do that. So we're going to square both sides. So we have cosine theta plus 1. We'll square that. And we have sine theta on the right-hand side, and we'll square that. Multiplying this out, we're going to get cosine squared theta plus 2 cosine theta plus 1 on our left, and then on our right, we have sine squared theta. We can plug in for cosine squared or sine squared, but notice that we have a cosine term. So we want to switch the sine squared to cosine squared. Let's do that up here. We know that sine squared theta is going to be 1 minus cosine squared theta. And we can plug that into our right-hand side. Our left-hand side is going to stay the same. And then on our right-hand side, we're going to get 1 minus cosine squared theta. Let's pull everything to our left-hand side. And actually, before we do that, let's notice that our 1's are going to cancel. We'll bring our cosine squared on the right over to the left. So we'll get 2 cosine squared theta plus 2 cosine theta is equal to 0. We can factor out 2 cosine theta, and we're left with cosine theta plus 1 is equal to 0. This gives us two equations that are going to reduce to cosine theta is equal to a constant. Our first equation is going to be 2 cosine theta is equal to 0, which gives us cosine theta is 0. And then our second equation is going to be cosine theta plus 1 is 0, which gives cosine theta is equal to minus 1. Let's now think about the quadrants. Since cosine theta is equal to 0, theta is going to be located at a coordinate point. And when cosine theta is equal to negative 1, it's also going to be located at a coordinate point. Let's now plot these. On our equation on the left, cosine theta is 0. Cosine is related to x, so let's plot when x is 0. That's going to occur at pi over 2 and at 3 pi over 2. And then on the right-hand equation, cosine theta is negative 1, so x is negative 1. And that's going to occur at just 1 point, and that's going to be at pi. Let's summarize these on the next page. For our equation on the left, we found that theta was equal to pi over 2 and 3 pi over 2. So this gives us pi over 2 plus 2n pi, and then 3 pi over 2 plus 2n pi. And between 0 up to 2 pi, we have pi over 2 and 3 pi over 2. For our equation on the right, we found that theta was equal to pi, and then we're going to add 2n pi to that. And between 0 and up to 2 pi, theta is just equal to pi. And n is an integer. You now have all the tools that you need to solve trigonometric equations using identities. Now you just have to practice and do more problems.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.